Alright, so today it's day 77. I did more lead code, so we are almost done. I did this one, also a hard problem, but I wouldn't say, and this one was not in essence quite hard. What is hard is to arrive to the solution, like to understand how can you come up with this and how do you associate like these possible solutions to this type of problem. And what we are asked is to given like some stream from data stream, so we're gonna be given like a number, but at every iteration we can either add another number or ask what is the median, and we essentially we want to be able to return the median at any point in a efficient way, right? So one way of doing it is just keeping every time that you introduce a number you do a sorting and then you compute the median, right? Because you just take the middle values. But making a sorting every time you add a number is not efficient enough. So one way of doing it is just finding the relationship between the median and splitting to arrays, right? So there exists a strong relationship, like a strong understanding between finding the median and splitting an array in two. And also with, and there, if you imagine this like as a network, there's also another edge connecting heap into this, because heap keep track of the minimum value. So you can understand you're going to have two arrays, and you can keep track of the minimum value, which is going to be if you have left and right array. Okay. So one example is that you could have like, I don't know, like an array like this. If you find the median, it's going to be the average of these two, right? If this is odd, then it's going to be just this number. You can understand this as making two different arrays, right? And you can, and this is quite similar to the other one, and you can map this into the solution because there was another problem, which was the binary search for two arrays. So we are given two sorted arrays. So the way to understand this problem is to find, right, to compare these values, right? So, and this one with this one. So there is this mapping, and this from this observation you say, all right, so I can keep track, I can divide the whole data stream as two arrays, but these two arrays are going to be heaps. So this is going to be one heap, and this one is going to be an actual max heap, and this is going to be a min heap, because the representation of this is going to be 5, 6, 7, like this 3, and the representation of this is going to be 1, 2, right? So at any point you can ask, at any point you can ask what is the root. Here I forgot. What is the root of the array? So the root is going to be 5, and this the root is going to be 2. In this case, the solution is going to be in the root of the right array, right? So the second observation is that you gotta maintain an invariant in the solution, and the invariant is going to be, in this case, we have like two possible cases. Either both of the arrays have the same quantities, or one of them has one more element. And the invariant we are going to impose is we're going to choose that the right array is going to be the one that can have more, like at most one more element. And that's intuition. So now for the solution is going to be when they have the same length, we're going to look at the max heap, the root of the max heap, and at the root of the min heap, make the average. And when it's not the same length, it implies that the one that it's odd, the whole array. Hence, you just take the element in the right array, the root in the right array. That's it. That's the whole intuition. So once you know the solution, the problem it's very simple. But what is difficult is to actually arrive to the solution. So we're gonna define both of the heaps, right? Which is gonna be the data stream. So every time we insert an element, we ask ourselves the two cases: are the heaps do the heaps have the same elements or not, right? And what would be the algorithm to perform if it's either one case or another? Because if we want to introduce this number, we would say, okay, just introduce it in the right one, because we want the invariant to be that the right one it's the one that can have more elements than the left one, right? But what would happen if the left one is actually like a 0? You don't want to introduce it here because you want to respect the order, because 0 is greater than the 2, right? So what you do is essentially you first push it into this number. Once you get the root, you can move this number here, right? And you still conserve the invariant that this one has more elements than the left one. So in pushing into the heap, in the other heap, you order, like you calibrate itself the list, and you can push it, you can pop it and push it back again into the other, into the one that you actually want. All right. So that's the whole intuition. So the first case is if both have the same length. So I'm gonna say self.length equal to length of self dot right. If both are equal, it means that we need to push to the left and then pop it and push it back to. So I'm gonna say that heap q heap q dot push. No, the name is heap push, and we're gonna push into self dot right. The thing is that the left array is gonna be a max heap. So one way to solve it is because by default every heap is a min heap. So we can just push the negative numbers, and then once we return the value, we can multiply back again by negative, and that's it. So we push minus num. Then we also do the heap push. Now of self into here is left. We push into the right one, the root of the heap of the left heap. So I'm gonna say heap q dot heap pop of self dot left, and the pop is gonna be a negative number. We multiply back again, so it's positive. So that's it. So if it's else, it means that the right array has one more element. So if we want to add one more number, we want to add it to the left array. But first we have to add it to the right array because we want to push an actual valid number. So first we add it to the right array, and then we add it back to the left array, and we have to pop from the right array. And to find the median, we can use essentially the same condition, because if they are both the same length, it means that we take an average of both the roots. So I can say return, okay, it's gonna be minus self dot left 0 because this is the root, plus, and it's negative because the left array have negative values, and self dot right 0 or 2, else we're gonna return just the right one. And we miss here p. And that was it. This is the solution, and that was it for today.